Hello, my name is Peter Fandel. I'm a product manager at Rocket Software for open source on z/OS, and I'm here to present to you a secure and easy software delivery and deployment system for the mainframe. So that system is Conda for z/OS. So Conda, although it was originally developed as a package manager for Python, it is much more than that, and it is not just for Python anymore. So a few things that make Conda special are that it is dependency aware. So what that means is that when you download a product from Conda, it automatically determines what dependencies and what versions of dependencies are needed in order for that product to work correctly. And it will automatically download and install all of those dependencies along with the product that you are actually seeking to install. As an example of the improvement there, using our old deployment system and delivery system for open source software, if you wanted to install Git on a z/OS, it was about 40 steps because you had to download, FTP, unpack, and then install 4 or 5 different products, each one about 10 steps. Now with Conda, it's a single command line instruction. Also, Conda is language agnostic and product agnostic and platform agnostic. So it's not just for Python. Conda can be used to download any product, and we are using Conda not only to download, deploy, deliver all of our open source products, tools, and languages, but we're also going to be using Conda to deliver Zoe plugins, both open source and commercial, for our Zoe customers. Additionally, Conda is an environment manager. What an environment is in Conda, it is a collection of products of specific versions that you can define on your system, and then activate and deactivate environments at will with a single command. So you might have a dev environment, a QA environment, a staging environment, a production environment, each one with perhaps a different mix of versions and builds, and those can be activated and deactivated as needed. So why Conda and not some other system? So first of all, having to do with cross-platform. So there's only 2 package managers, Conda and NPM, that are 100% cross-platform. And NPM, however, though it's cross-platform, is really synonymous with JavaScript and tie-ins to browsers or Node.js. Only Conda is unassuming of the software to be delivered. Also, we've modified Conda for z/OS to handle file tagging. And most importantly for the mainframe community is the issue of security. And where that comes in is how you store products for delivery by Conda and how you deliver those to the end user. So Conda does this through something called a Conda channel. A Conda channel is a repository of products that have been built and packaged for Conda delivery. And there's 3 kinds of channels. There is the public internet channel shown on the left, and you'll find hundreds, perhaps thousands of public Conda internet channels out on the internet. Most of them are freely accessible. You don't need to log in, and you'll find thousands, tens of thousands of different open source products available for download from public internet channels. Then you have, for those that are more security-minded, you have private internet channels, which are authentication secured. These are usually on private vendor networks behind the firewall. And you can, if you have an account on one of these private internet channels, then you can download products from those. And finally, for the ultimate in security, there's something called a file channel, which is ideal for air-gapped mainframe systems. And a file channel can be set up on-premise for use within your organization for downloading. And it's the same Conda commands for downloading from a channel, regardless of whether it's a file channel, a private internet, or a public internet channel. I'll be demonstrating all three of these in just a moment. So the workflow for setting up and using Conda on your system is as shown here. On the left side is the bootstrapping step done by an administrator. This only has to be done once. That's why I grayed it out a little bit. It is just a one-time thing, just installing Conda onto your system. So you can't install Conda using Conda, so that's why it's a bootstrapping process. Anybody can go to the Rocket support portal, don't need to be a customer, and download the mini Conda installer, transfer that onto your mainframe and run the installer, and that will enable you to then run Conda commands from your system. From that point onward, it depends on whether you are using an air-gapped system or not. So if you're okay with your organization going to a secure private vendor channel server or a public channel server, then you can immediately instruct your teams to begin using the Conda installation to download and install whatever they need from those channels. If you have an air-gapped system, there is an additional administrative step shown at the bottom right as step 1B. The administrator would need to download a solution bundle containing all of the open source products that they want to make available to their teams and use that to populate the on-premise file channel. At that point, then the internal teams could download and install from the file channel at will. You would have to redo this periodically to refresh the contents of your file channel. So there's a little bit of a maintenance overhead to using a file channel, but it's still a significant improvement over the existing methods for software delivery on the mainframe. Then it comes to developing for delivery by Conda. So if you have development teams developing your own in-house tools or products and you want to make them available internally using Conda, it's pretty straightforward. You need to create a metadata file, meta.yaml, for every product you want to deliver by Conda. This metadata file specifies the name of the product, the version, the platform that it runs on, and all the dependencies and versions of dependencies, as well as the location of all the source code for creating that. And then you create a Conda build script that builds that from the sources. Optionally, you can also add scripts that are automatically invoked by Conda immediately after install and immediately before removal for uninstall. Examples of all this are available at the URL specified. It's a publicly available URL. Now on to demos. So I'm going to show you first installation of Git, first from a public channel, then from a private channel as the first demo. So let me go there next. So first I'm going to show you what it looks like on a public channel. So here we have the URL. This public channel called ZOSS DevOps is hosted by anaconda.org. And here you can use the browser interface to view all of the different products that are available. So you can see Bash, Git, gzip, etc. And so any one of these, you can click on it. You can see the license. You can see the number of downloads, the version. You can also click on the Files tab and see the actual package and download that, but that won't be an installation. That will be just downloading the actual package for inspection, perhaps. But for download and install, you need to use the Conda CLI, the command line interface. And so I've got a mainframe login here. And what I'm going to start with is to do a Conda info command. And this tells me I've got no active environment yet. Tells me the version of the Conda and of the Python. But the important thing I want to show you is the channel URLs. So this particular Conda installation has been configured with a default channel specification to that public anaconda.org channel. I'm going to show you how that was set by displaying the contents of the Conda RC file. That's the configuration file for Conda. We can see that the administrator specified a particular default channel and also disabled use of other channels by setting allow other channels to false. This is probably a good idea for mainframe data centers because there's a lot of open source that's been ported to the mainframe, but still the vast majority of public channels out there contain open source that is not specifically for the mainframe. So if you want to save time and focus your developers and have them only access known good sources of open source for the mainframe, you may want to do something like this. So the next step as a consumer of open source is, well, if I want to install Git, let me see what's available. So I'm going to do a Conda search Git. And now it's going to be looking in the Anaconda public channel to see if Git is available. The public channels are a little bit slow. You'll see a dramatic difference when I do the same thing on a secure private channel. So yes, it tells me that Git 2.14.4 is available. So the next step would be for me to create an environment into which to place this. So I'm going to create an environment called test. And once that's done, I will install Git into that environment. First, I have to activate the environment. Okay, proceed. Now I will activate the environment. Again, these steps only have to be done once to set up the environment. So now the environment is created and activated. The command is conda install git. That's it. Again, this is a bit slow because the publicly hosted internet channels are pretty heavily used, the servers at Anaconda, so this is a bit slow. Still only takes a few seconds. So you can see it automatically determined all the dependencies and specific versions of those. So now when I say proceed, it's going to download and extract and install all of the dependencies as well as Git. So now, just to show you that my Git has been installed and is running, I can say Git version. I've got 2.14, and you can see if I say which Git that it is installed into the test environment where all my environments are stored under Miniconda. So now what I'm going to do is I'm going to do the same operation, but instead I'm going to go to a secure private internet channel. So here we have at condaserver.rocketsoftware.com, that's Rocket's secure Conda channel server. And you can see all of the products available on this. And for any one of these, there's a bit more features here because you can also view the dependencies. For Bash, there's no dependencies. And you can see the dependents. So Git depends on Bash, so that's listed here. Also, you can see what's coming in the near future is we're going to be integrating in CVE information for every one of the products and versions available on our channel server. So now going back to the mainframe, I'm going to change the configuration to a different configuration for this part of the demo. So dot conda rc demo 1b. And do another conda info. So now you can see I've got an active environment from the first part of the demo set up. But the important thing here is that now the default channel has been changed to be the private Rocket Software channel server. And so now if I do the same conda search git, first of all, it responds right away. It's much faster. And you can see that on the Rocket private channel server, we've got 2 versions of Git. There's a more recent version available, 2.26. And now I'm going to create another environment. This one I'll call production. And in the same command, I'll tell it, create that environment and immediately download into it Git and all of its dependencies. So you can do that in a single command. All right, now I'm going to activate this new environment. And now when I say git ---- version, you can see that I'm running git version 2.26. Now for the second demo, I'm going to show you installation of a Zoe plugin from a file channel. So conda info here, this is a different mainframe system I'm logged into. No active environment here, as you can see. And the channel, the default channel specified here is a local file channel. So here, I'm going to first do a search. I'm looking for a particular Zoe plugin that I want to use as my 3270 emulator. So I'm going to say conda search. It's called Blue Zone. So I'm going to say Blue Star. And it tells me that indeed, Blue Zone Web as a Zoe plugin is available on our file channel. And now I can do that same single command to conda create a new environment called production and download into that environment Blue Zone Web. What did I get wrong here? Conda create -n production Blue Zone Web. I must have already used that. Let me try production 2. There we go. Yes, no dependencies. So now we're going to install Blue Zone Web onto this system. And you'll note the output from this command is a lot longer, a lot more text that you'll see fly by when it finishes the download, because this particular Conda product has a built-in post-install script that moves around all the files necessary to make it a Zoe plugin, sets environment variables, etc. Okay, so that's now done. I'm going to activate production 2. And now I can run Zoe. Start up Zoe. That's Zoe in internal run Zoe. All right, now while that's starting, I'm going to go to my web browser where I've got a tab for logging into the Zoe desktop. Hopefully it's fully started. Let me refresh that. Okay. Oh. There we go. So here's the Zoe desktop. I'll enter into full screen mode. And if I go to the Zoe Start menu, you can see that we now have, in addition to the free built-in terminal emulator, we have Rocket's Blue Zone Web terminal emulator. And some of the advantages of the Blue Zone Web are you can define your own sessions. So create a RS-22 session type 3270. We want to go to RS-22 as the host, add it, and then click on that to log in. And there you have it. So the Blue Zone Web has hotkeys and scripts, recording capability, et cetera, a bunch of features not available in the free emulator, which is why I wanted to download this. And that's it. So any questions for me? Let's switch to the last slide, which is just a big Q&A.